Today is day 12 of 30-day lead coding challenge, and today's problem is last stone weight, and it's also a lead code problem number 1046. So let me explain the problem. You are given different stones. These numbers denote the weights of different stones, and the weights can be only positive. You can think of weight or mass. Unit of mass is kg, weight is Newton. So let's think them of stones masses, and this can only be positive. So your task is that at each step you will pick the two heaviest stones, in this case 7 and 8, and you collide them. And if you have stone 1 and stone 2, so you collide them against each other. So if this result will depend on two things. One is that S1 equal to S2. In that case, both will get destroyed because their weights are equal. And the other case is that S1 is greater than S2. This can also be S2 greater than S1. That is, they are not equal. So better write not equal. Then the result will be that the smaller one will get destroyed and the difference of S1 and S2 will remain. So we will replace. So first we have to remove these two, and if the difference is 0, then we will not add anything. If the difference is there, that is, they are not equal, then we will add this difference. Let's call it delta. So now it will become delta. In this case it will be 1. So let's add that. So it becomes 2, 4, 1, 1. These are the remaining elements. And we added this delta, that is 1. So this is after one step. Next, what are the two heaviest? 2 and 4. Difference is 2. Here the difference was 1. So remove these two and add 2. So we get 1, 1, 1 and 2. Now the two heaviest are 1 is 2, and you can pick any of the ones. So you get a difference of 1. So we get 1, 1, 1. Now the two heaviest are any of the two ones, and the difference is 0. So they disappear. So we are left with 1. So there is only one stone left, so you cannot collide it against any other stone. So in this case you will return 1. This is the answer. If anyhow we did not get that, let's backtrack and see what can be the case. Let's say here we were 2 was already there, and let's say we got 6 instead of 7. Then the difference would be 2, and we would have inserted 2, 4, 1, 1, 2. Then 4, 2, difference would be 2. So we would have got, let me write it, 2, 6, 4, 1, 8, 1. So 2, 4, 1, 1, 2. 2, 4, 1, 1, 2, 2. Then 2, 2 gone, 1, 1 gone. So nothing is left. It's empty. So we will return 0. So either the answer will be 0 or 1, depending on the last stone, whether it remained or not. So you can do one thing, that a naive way would be that you iterate the array. You keep track of min and first max and second max. So that will take order and time. Then you see the difference, and if there is some difference, you insert that. Again, you will do n-1 or n-2 steps, so that if you see, so either n-1 or n-2, and depending on this, plus either you decrement by 1 or 2. So that way it will take order in square. Similarly, if you sort the array beforehand also, then you will pick two elements from one end. Then in order to insert that, you will have to look where to insert. So that will again be an log n operation. So we will propose a different solution here that will be using max heap. So remember the property of heap. It can be max heap or min heap. And we are talking about binary heaps. So if it's a min heap, then this is the minimum. The root is the minimum element. And for any node, its children will be larger than this node. And this will hold true for all the nodes. And one additional property is that all the levels are filled except the last level. And last level is left filled. So till last -1 level, everything is filled. And whatever elements are left, they will be towards the left. So it's almost complete binary tree. And this is the property in min heap. All the descendants, left and right, will have value more than this. Similarly, in max heap, this element will be the max, and its children will be less than this. And this will hold true for all of the nodes. So building the heap is order n operation. If you are given n elements and you are asked to build heap from it, it will take order n time. So you build the heap in order n time. Then getting the max is constant because it's the root. So you get the maximum, so 1 unit. So this is one-time thing. These will be done for different iterations. So you pick the max, you do heapify again. So that will be log n time. Then you pick max again and do heapify again. So again, double of that. And this you will do n times. So you can expect n log n complexity here. And when you get a difference, you push back into the heap. So it will be inserted in the end. And then you do heapify again. So again, that in each iteration, we will do log n operation. So let's look at this solution. If you want, we can see the running example of this also. Let's say the heap was 8 would be at the top, then 7, 4 or something like that. It doesn't matter. We pick 8. We do heapify again. So 7 will be promoted here and the heap will become 7, 4 or something like that. We pull out again and we heapify again. So it will be 4 and the remaining elements. And we inserted the difference 1 in the end and we do heapify. It will remain same. And this way you can draw the heap. But that is not important. It's important that we pull out the maximum twice and heapify twice in each iteration, and that will take log n time. So let's see the code for this in C++. So this is the explanation of the same thing. In C++, we have make heap, pop heap, push heap. These are the operations that are available in algorithms package of STL. So we can make a heap out of a vector. And this takes the 2 iterators from where to where you want to make heap. So we will heapify the complete vector. So it's now a max heap. By default, it will be max heap. If you want a min heap, you have to specify here the greater operator. By default, it's less operator and it makes max heap, and we exactly need max heap for that. Now we have to continue until stone size is greater than 1. So if it becomes 1, we cannot do anything. If it becomes 0, then also we have reached the end. So we pop heap. So what this pop heap does is it picks the largest element and puts to the end as the last node. So it's not yet removed. So in this case, 8 would not be yet removed, but it would be pushed to the last. So we can get the largest value using stones dot back. Now we can remove it. So we will do stones dot pop back. So now the largest element is removed and we got the largest stone rather. So this was the way of finding the largest. We will do the same thing for second largest. Name it Y. And its second largest stone, again pop back, diff equal to absolute value of this, and if diff is greater than 0, then so we have just pushed it to the end of this vector or heap, but then again we need to heapify it also, so we have to do push heap operation on it. So now it will do the heapification after pushing the difference, and this loop will exit when the size becomes 1 or 0. So if stones dot size equal to 1, then we have to return that. Stones 0. I think I made a mistake during explaining it. I said that output will be either 0 or 1. That is not the case. Output will be either 0 or the remaining element. Yeah, the 1 was, I think it's coming from the example. It's just a special case. It can be any value, the last element. So that I think said wrongly. And if its size is not 1, then we will return 0. That is, all the stones have been destroyed. Now let's check it. So it works. Let's submit it. And our solution is accepted. Now let's go back to LeetCode problems, because I said this is also a existing LeetCode problem, which is 1046. Let's refresh it. It should pick the solution here once you refresh, and it happens the same way. If you first write here and go to the contest and refresh there, this solution will be copied there also. So here I wanted to see how efficient our solution is. So this is the submission that we made a few seconds ago on the contest website. There the time was 0 millisecond, so there is some difference. We can try again. And now we get back 0 millisecond, and you see our solution is quite good. It's 100% better in terms of memory and space for all the C++ submissions that were accepted. So I hope you understood the problem. It's mainly about knowing these things in C++ library. The concept was pretty simple using the max heap.